Hello everybody, this is Miss Bryant, and today I will be doing lesson 12 with you guys, which is on using equations of lines. So I'm going to switch over real quick to the lesson PowerPoints, and we're going to get started. Alright, like I said, we're doing lesson 12, which is using equations for lines. Our target is being able to write equations for lines that's given to us. The way we're going to measure our success criteria for today is by being able to find an equation for a line and use that to decide which points are on that line. All right. So we're going to start off with our first activity, which is writing relationships from 2 points. As you guys can see here we have a line. There's 2 points on it identified for us, and then we have a point right here known to be x, y. These 2 points are easy for us to identify because they perfectly are in the corners. So it's easy to see that that's 5, 3, that's 7, 7, but this one is not perfectly in a corner. It is in a place in the space of the square. So we can use what we know about slope and writing equations from lessons 10 and 11 to possibly help us figure out what that point could potentially be. So first, let's look at our questions and see if we can answer our questions here. Question 1 says, what is the slope of the line? So at lesson 10 and probably a little bit in lesson 11, we use what was called, or what's known to be, slope triangles. So if I create a slope triangle, I can use that to help me to find the slope of my line. So I'm going to use this point. I'm going to draw a triangle that will lead me to this point here. So here's my slope triangle. And I can use that to find the slope of my line. If we remember from lesson 10, slope is the vertical length divided by my horizontal length. So let's find out what our vertical and our horizontal lengths are. So my vertical is 1, 2, 3, 4. My horizontal is 1, 2. So that means my slope is 2. And what I'm going to go ahead and introduce you to is, if you haven't already been introduced, variable m is typically used to represent slope. And you will see this throughout your mathematical career in school. M is used to represent slope. So I'm going to stop using S, and I'm going to start using M to represent slope, just to get you familiar with the actual terminology that's being used. Now it's asking me to write an equation for the line in the diagram. Now, if the line was starting at 0, 0, its initial point, or its initial starting point was at 0, 0, then my equation, based off of lesson 11, would probably be just y over x equal to the slope. But because my initial starting place is obviously not at 0, 0, I have to write my equation differently. Again, which is what we hopefully learned in lesson 11. Now there's 2 equations I can write for this line to represent it, and both would give you the same answers. First one I would write is y minus 7 over x minus 7 equals 2. or y minus 3 over x minus 5 equals 2. If I take the point I don't know and subtract them from the points I do know and set that equal to the slope, that could possibly help me find that point, and that is how we're writing our equations as of now. So either one of these two would be good equations to use for this graph. Question 3 is asking, is the point 9, 11 also on the line, and how do you know? Well, what I could do here to find out if 9, 11 is on my line is to plug it into my equation to see if it will give me the same slope. And here's what I mean. 9 is representing x, 11 is representing y. So if I was to plug in these values into the equation, it should equal 2 at the end. So let's see what that actually looks like. If I put in 11 for x, and not 11 for x, I'm sorry, 11 for y, and 9 for x, it says that when I solve it, I should get 2. So 11 minus 7 is 4. 9 minus 7 is 2. When I do 4 divided by 2, I get that 2 equals 2. So yes, the point 9, 11 is on this line, and I know because when I plug the point into my equation, it gives me the same slope. Now, if you want to try in the other equation just to make sure that you're right, especially if this is the equation you've written, we can do that as well. So 11 goes in place of y, and 9 goes in place of x. And when I solve it, it says I'm supposed to get 2. So 11 minus 3 is 8. 9 minus 5 is 4. And that's supposed to equal 2. When I do 8 divided by 4, 4 goes into 8 2 times. So yes, it works on both equations. So again, I just proved with both of my equations that the point 9, 11 is on the line because it gave me the same slope that the equation says I'm supposed to have. So now my next question is asking me, well, how about the point 100 and 193? Is that also on the line? Well, just like I did for question 1, I'm going to do the exact same thing and plug in those points into either one of the equations. And again, seeing how it works regardless which equation I use, we don't really have to go through and check with both. We're just going to pick one. So I'm going to go with our first equation here. So I'm going to write down which equation that we're going to use. Okay, so 100 is x, 193 is y. So 193 minus 7 over 100 minus 7. And that's supposed to equal and reduce down to 2. So 193 minus 7 is 186 over 100 minus 7 is 93. And when I simplify that, that's supposed to give me 2. If I do 186 divided by 93, I actually do get 2 as my answer. So yes, the point 100 and 193 is on the line because just like question 3, when I plug it into my equation, it simplifies it down to the slope that the equation says I'm supposed to have. So now to make sure that you guys understood what we did here, I do have an on your own question. I'm going to give you guys a few minutes on your own to work it out, and then I'm going to go over those answers to make sure that you got the correct answers and that you understood what you were doing. So I'm going to give you a couple of minutes to complete the on your own question. Okay, now question number 1 says to find the slope. So I'm going to find my slope by connecting my 2 points on the line here. If there wasn't 2 points already identified for you, what I would suggest that you do is pick 2 points on the line that goes perfectly through the corners of the squares and create your own slope triangle. Because one thing you should already get used to, or at least know, is that you will not always be given the 2 points. There will be instances where you have to pick your own. So now my slope is the vertical length divided by my horizontal length. So let's find out what that is. My vertical is 2. My horizontal is 1, 2, 3, 4. So that means my slope is 1/2. Okay, now I need to write my equation. You can write one of 2 equations here. I'm going to write both. Since this line does not start at 0, 0 as its initial value, you're going to write your equation either like this, or you can write it like this. Either one of those 2 equations would fit for this line. And then last, it says, how can we find whether or not the point 7237 is on the line? Well, you can find out by plugging in that point into any one of those 2 equations, and it will let you know, or basically tell you whether or not it is an actual point on that line. So let's do just that. Let's use this equation. This is x and that's y. So 37 minus 2 over 72 minus 2 is supposed to give me an answer that reduces to 1/2. 37 over 2 minus 2 is 35. 72 minus 2 is 70. 35 goes into 72 times. So that's 1/2 equals 1/2. So yes, this point lies on the line because when I plug it into the equation, it does reduce down to the slope, which the equation says that it should. All right, so now to our last activity, which is dilations and slope triangles. Here we have triangle ABC. And question 1 wants us to dilate triangle ABC with 0, 1 as my center and a scale factor of 2. Remember, with dilations, you must know the center and you must know the scale factor. All right, so my scale factor is 2. So that basically tells me that each point on the triangle is going to be twice as far away from my center of dilation. So A is on the center of dilation, so that's not going to change. B is 2 units to the right of my center of dilation. If I multiply by a scale factor of 2, B prime is going to be a total of 4 units away from the center of dilation. C is 2 units to the right and 1 unit up. So if I multiply that by 2, let me write that down for you guys. I'm sorry. To the right 2. So B prime is going to be to the right 4 because I'm multiplying this by my scale factor of 2. C is 2 to the right and 1 up. So if I multiply that by my scale factor of 2, C prime is going to be to the right 4 and up 2. Question number 2 says draw the dilation of triangle ABC with center 0, 1 and a scale factor of 2.5. So I'm taking the original and I'm dilating it by a different scale factor, which is 2.5. So B is 2 units away. So B prime is going to be 2 times 2.5. Which is 5. C is 2 to the right, 1 up. So I'm going to multiply that by 2.5. So C prime is going to be 5 to the right and 2.5 units up. I'm sorry. That's going to be B double prime. That's going to be C double prime. So that's what it would look like. And then our last question says, for which scale factor does the dilation with 0, 1 as my center send C to 9, 5.5? 5.5. Explain how you know. So we have to figure out what the scale factor is. So if I graph this, if I find out where 9 is, and then go graph where 5.5 is, here's 5, and there's halfway. So that tells me that B triple prime is going to be here. C triple prime is going to be there. I'm going to use a ruler to make this a little bit more straight. Okay. So I have just moved this point C to 9, 5.5, like question 3 asked. It wants to know what that scale factor is. So to find out what the scale factor is, we have to remember that the scale factor, let me write it out for you, is the image over compared to divided by the original. So we need to find the distance away each one is from the center of dilation to help us to find the scale factor. So if we look here, AB is 2 away. So segment AB is to the right 2. Segment AB double prime, which is the length of the pencil written circle, not circle, sorry, triangle, is a total of 9 away. Segment BC is up 1 unit. Segment B triple prime, C triple prime is up a total of 5.5 units. So what you would do is you would find the scale factor of how many times it moved to the right and the scale factor of how many times it moved up. No, I'm sorry, not 5.5. 1, 2, 3, 4.5. Sorry, you guys. 4.5. And compare these and see what you get scale factor wise. So again, you would find the scale factor of how many times it moved to the right and the scale factor of how many times it moved up and compare them. If they're the same, then there's a scale factor. If they're different, then there's not really a scale factor, and so one cannot be determined for this question. So I'm going to do the image of going to the right. The image is first, which is 9, then the original, and then going up, the image is first, and then the original. 9 divided by 2 is 4.5. And 4.5 divided by 1 is 4.5. So my scale factor here is 4.5. And so that's how C moved to 9, 5.5, because the original was multiplied by a scale factor of 4.5 to move it there. What you should see or notice with this is how our line here is drawn. All these triangles are on that same line, and these triangles are all dilations of each other. And all of these dilations fit on the same line. So each one of these triangles have the same slope or has the same scale factor in some sense, because they're all on the same line and they all will simplify to the same thing. So what we need to understand here, or the big thing we need to understand, especially with the last activity, is that the structure of the coordinates of the points on the line can be derived from properties of scale of dilations. So these are all dilations of each other. If you look at any of the previous activities that we've done, like with lesson 10, when we looked at all of those triangles on a line, all of those triangles were all dilations of each other. They're all dilations of the original. It's either a bigger one or a smaller one. So we can use what we know about dilations, which comes from transformations, to help us to find slopes of lines. So that is it for lesson 12. Hopefully you have an understanding as to how to use the equation of lines to find out if a point is on that line. If you have any further questions, you can contact your math teacher, whether it's Miss Bryant, Miss Wallace, or Miss Looney. Other than that, I hope you guys have a great day. See you later.